Here's another example. A rainbow loom had 4 blue and 12 yellow rubber bands. Make a graph that can describe this ratio. Now, this problem, you're given a lot less information. You'll notice that the grid has nothing labeled. I don't have any numbers there. I don't have anything labeled in terms of what my axes should be, and we're going to have to fill that in ourselves. You might also notice that the ratio that I gave you, 4 to 12, isn't in lowest terms, 4 to 12. So before we put that into our table, let's put that into simplest form. So 4 to 12 reduces to 1 to 3. So I'm going to start with that, 1 to 3, and then I'm going to follow that, 2 to 3 to 9, and then the one that was given in the problem, 4 to 12. Now there's any number of points that you can use here. Okay, I just used 1, 3, 2, 6, 3, 9, and 4, 12. Let's make our horizontal axis right here, let's make that our blue. That will represent our blue rubber bands. Make our vertical axis represent yellow. Okay, and I know that might be hard to see, extremely hard to see, but that'll be yellow. All right, so if I look at my blue numbers, they go up 1, 2, 3. I am going to space it out a little bit, okay? This 0 always goes here. That's our origin. And I'm going to make a mark every 3. So I'm going to make that one 1, and I'm going to space it out every 3. 1, 2, 3. So that will be 2 blue rubber bands. This will represent 3. This line right here will represent 4, 5. Even though we don't really need those numbers, I'm just going to fill it out just to make it look good. And then our rubber bands are going up by 3s. So what we might want to do for our rubber bands is, we don't necessarily have to label every single point, though I'm going to label every other. So this is 2, 4, 6, 8, 10, 12, 14. Because it just gets kind of crowded if you try to put all those numbers in there. And we can all figure out what's in between the 2 and the 4. We know that this is 3. We know that this right here is 5. We know that this right here is 11. It's all implied. It's there. You don't have to write the number in there for us to know what it is. So now let's graph it. Okay, so if there's 1 blue, that equals 3 yellow. Point right there. So 1 blue is equivalent to 3 yellow. Next, if I have 2 blue right here, there are 6 yellow. So 2 and 6 would meet up right here. 2 blue is equal to 6 yellow. On the horizontal axis, it's pointing to the blue, and on the vertical axis, it's pointing to the yellow, 6. On the next one, 3, 9. So I'm going to find 3, and then I'm going to go up to 9. The 9 is in between 8 and 10. And at this point, you should notice, looks like our points are very much linear. They are making a line. So this is definitely the right thing. And then lastly, let's do 4 and 12. Okay, so 4 right here. And then I'm going to follow this up until I get to something that equals 12. There you go. So you'll notice when we're done with our graph here that we have a line. It doesn't curve. There's a definite progression to it. It's linear. What's linear mean? It means it's a line. And another thing, too, that I haven't really mentioned yet is that if you're dealing with equivalent ratios, if we're dealing with those equal ratios, we better make sure that our line starts off at 0, okay? If it starts off here, for instance, and goes like that, then we're not necessarily talking about equivalent ratios. Even though it is linear, I don't think we're dealing with equivalent ratios. So you definitely want your lines to start to have their origin at 0. Otherwise, it's not equivalent.